This is the 2018 higher level section A. And this is our paper. So you have 4 questions presented. You need to answer 3 of them. So we're going to go through each one of these individually. Okay, first question is an axonometric projection question. The 3D graphic shows a bicycle shelter. The drawing shows an incomplete diametric projection of a similar shelter using the axonometric axis method. The horizontal plane is also included. The complete, as for question part A, is complete the axonometric projection of the bike shelter, and part B is a line joining Y to B, so Y to B, represents a straight line path of a football. Show the point of impact of the ball with the glass roof in the axonometric view. So I'm going to start with drawing the shape first. So start with the basic outline. Okay, going to need sliding set squares for this one. So taking your lines, going to start with just the basic frame of the shelter itself, and then we'll do the bits in the inside. So these lines here project down from the top, so this one next is this point up here. That's one piece up on top. The one at the back then, that's the same, so we can take this line that's projected down along this way and bring that from the end view, we'll call it. So this comes down along this way. So this is the back of it, and that point up there will be the top. So it does overlap somewhat, so joining those 2 up, this one up to the top of it, and this one down here also. Okay, so we need to find now our points on the ground. So we have the top of the shelter, now it's the bottom. Let's get a reflection on that. Yep, it's better. So extending these lines down along this way now. So this one, and at the back also. And going to take, so I brought down the 2 bottom points, so I'm going to take where they would be here. So they're coming from back up here now. That gives us this point and this point here. So again, we can join those up, find the side of the frame. And here also. Okay. There doesn't appear to be a line across the bottom here. There's no dark line, so we don't need a dark line down here. Next bit is the 5 bicycle pieces on the inside. So they've given us our backline. One of them, it essentially runs through the inside of that there. So they're the kind of the higher ones. We're going to work on the lower ones here now. So I'm going to start with the points on the ground. So I'm going to take this point here first and find those on the ground. So taking this line, projecting this down this way. So somewhere along there are going to be my points on the ground. I'm going to do the ones above that now as well. So there's starting to be a lot of lines coming down through this. Taking this one, they come down along here. So what I'm going to do now is I'm going to find the front and back. So we have this line, that's this one, and we have the front line. They're both going to be on the same point at the front. Do something about that light. Shadows. So taking this first one, they give us the back one, project this down, back point and the front point. Sorry, front point is here. And the next one, projecting that on, back point here, and this is the front point. So on the red line and the pencil line we brought down. And here also. So they're the points on the bottom. Now we're going to find the same points up on the top. So taking our lines from the top of these here now. So that'll give us the ones at the back. We'll have to do a little bit more than to find the ones at the front. So taking this point, that's the one at the back. one here on the red line. And that bit there also. Okay, so we're going to join some of these up now first. So these are the outermost points. So there and there. I've already given us that one, so the next one in is this one. Next one in is here. And this one here. So they're the back of the frames. We still need to find the lower points down here. So as you can see from this, these are not at the same height. So we need to locate the height of them. So taking this height here and across, it's just going to give us a measuring line, so we can measure what this height is here over from B or wherever, and transferring that distance up. So that's the height that these are at, and so just using this blue line just for measuring off of that. So we can take each point now down from our elevation into the axonometric view. So that's this point here, comes down until it intersects with this line coming down along this way, so that would be this point here. Same for the second one. That's this point. Here. And that point. Okay, so we can join the last ones up. So 1, 2, 3, 4, and 5. And then finally we need to put on the top bar. So we already have the each point, so this is going to join across. This is a lot of lines inside this question. And we're not there yet. So that's the frame part of it. There, the bike stands. And there's still a few other little bits that we need to do. You notice there's a line coming across up here. That is this bar. So there's an extra bar on that. So we need to locate that. So that's done the same way as locating every other point. So taking this, projecting it down until it intersects with this line. So it's going to be there. Same on the other side. There. And we can draw a line joining the two of them. So that's the top. And that there completes part A of this question. Second part of this question is we've got the ball, the flight path of a ball going from Y to B needs to pass through the roof here somewhere. They give us Y and B in the end view, so we're going to use that. So joining Y to B, we can see where it hits the roof. So it's going to hit it at this point, but that doesn't show us how far along the roof it is here. So again, joining Y to B up here in the axonometric view, Y to B down here. So Y to B, so we can see this line Y to B here. Where this point intersects that line, it's the same point on the same line. So taking this line, this point, finding that on the same line, down here, that point there is the point where it intersects. Okay, so what we've done is we've joined Y to B in the end view. We can see where it hits the roof. Drawing the same line Y to B in the axonometric view. We need to project this point from the end view into the axonometric view where it intersects the line YB. They're the same line. That gives us the point of where the ball is going to strike the roof. And that completes the A1 question. Question A2 is a skew lines question. So the graphic below shows a group of fishermen. 2 fishing rods are presented by the skew lines AB and CD on the right. AB and CD. Determine the projections of the shortest horizontal line between the 2 skew lines. And then part B is determine and indicate the distance from this line to the horizontal plane. So the horizontal plane in our elevation will be the XY line. So first thing we need to do is we need to create a lamina. So a lamina is part of a plane. So at the moment we can't do much with this question. We need to find a horizontal line on this, and the reason we're going to find a horizontal line is so that we can create a plane, and once we have a plane we can look along it, and then when we look along it we'll be able to see the 2 lines parallel to each other. So to start this out, we're going to create a lamina. So the lamina that we're going to create is going to use both lines and a horizontal line. So what we're going to do is we're going to take the line CD, and I'm going to put that onto A. So point C goes onto A up over here, up along here. So this line is parallel to this line. They're parallel to each other. From there I'm going to take a horizontal line from B. And the reason I'm taking a horizontal line here is because that will be a true length down in plan. So if something is horizontal in the elevation, it's a true length in plan, and vice versa. So I need to do the same thing now down in plan. So I took CD, I put point C onto A, so I need to do the same thing up over here. So parallel. So it's the line CD here is parallel to this line up here. I need to locate this point. We can call it Z. I'm going to locate point Z, and I need to locate that same point now down in the plan. So taking this point, projecting it down, giving me point Z down here. So just like in our elevation, Z joins to B, so Z is going to join to B down here. What this has done is this has created a true length line for us. So this line Z to B is a true length. If it's true length, I can look along that line. So what I'm going to do now is I'm going to look in perpendicular to it. So projecting this down along this way, looking along that line, and I'll put in an X1, Y1 line down here somewhere. So this can go anywhere down here. X1, Y1. What I'm going to do from here is I'm going to project each of the points A, B, C, and D down from there. So A and B has already gone up. C and D. And I'm going to be taking the heights that they are. So whatever height something is up here, this is now an auxiliary elevation. So heights are going to transfer between the 2 views. So taking my heights, I'm just putting a vertical line down so that it's a bit easier to measure. So measuring the height of A above the XY line. So copying this distance there to there. Call this A1 or A. Do the same thing for B. C and D are the same. We transfer them the same way, and C and D. So B, C, and D. So joining these up now, and if done correctly, these lines should be parallel to each other. So this is our first bit of setup that we need to do. What we need to do now is look back at our question. So it's determine the shortest horizontal line between the 2. So as it's a horizontal line, I'm going to look in horizontal. So horizontal would be looking along the X1, Y1 line. So I'm going to look in along that. So I'm going to look along this line here. So again, I'm going to draw an X2, Y2 line. This time the X2, Y2 line is perpendicular to the X1, Y1 line. And I'm going to project each of these points up. So taking each point, so this is point C, A, D and B. So again, just like we did the last time, when we were measuring for here, we skipped this view, measured from here. This view, marking here, skipping this view, measuring from here. So we're going to measure from our x1, y1 line back to each point. So from this point back to A, from this point back to C, taking point B as well. So measuring from the x1, y1 line back to each point. So again, joining up all our points, A to B, and C joins to D. Where they appear to cross each other is the position of a horizontal line. So what we can do is take this point, we're going to project it back. It'll be horizontal down here. We'll project it back up here. It won't be horizontal in this view, but it will be horizontal back up here then again. So taking this, projecting this back down. And a different color. That's the horizontal line in the auxiliary elevation. Need to project this back now into the plan. So that's on the line AB, so that's going to be this point, and onto the line CD. Up there. So joining the two of these together. There are the projections of it in the plan. And up into the elevation now again, so vertically from the plan up to the elevation. And this is a horizontal line there. So the question asks us, determine the projections of the shortest horizontal line between the two skew lines, and determine and indicate the distance from this line to the horizontal plane. Okay, so the final part of this, determining and indicate the distance, that's just, you need to draw a line up at the side. You can use a different color or whatever you want to indicate it with. That's height h here. Determine and indicate the distance from this line to the horizontal plane. The horizontal plane in the elevation is going to be the XY line, so this will be the height for that.